For topic 3, we're going to look at understanding the addition and multiplication properties of equality. In an earlier video, we were talking about kind of like what is an equation. An equation is a mathematical statement that says two expressions are equal to each other. And what that equal sign does is it gives us the ability to solve the equation, which means we isolate the variable to determine its value. And at that time, I mentioned that we have to maintain balance. What that means is this. When you're given an equation, whether the left and the right hand side look equal, they are said to be equal to each other. And our job is to figure out which value for the variable is going to make that truly equal. Okay? So as we're solving this equation, as we're taking those steps to isolate the variable, which means we kind of undo what has happened to the variable, as we're doing that, we have to maintain balance. So that balance that naturally comes with that equation, we have to make sure we keep that. Okay? So the first thing I have here is just kind of a reminder, okay? So I have here, when given an equation, the equal sign indicates that the equation is balanced, meaning the left side equals the right side. Our goal is to maintain balance in the equation while we're solving. So really what that means for us is whatever we do to one side of the equation, we have to mimic it on the other side of the equation. And there are two properties that really allow us to do that. We have the addition property of equality and then the multiplication property of equality. So looking at the addition property of equality, it's the property that allows us to move terms from one side of the equation to the other by performing the same addition or subtraction on both sides of the equation. Okay? So we're going to say that we have A, B, and C. A, B, and C are going to be real numbers. That means they can be whole numbers, they can be integers. Integers are like whole numbers and then their opposite counterparts, so those negatives. We could have decimals, we could have fractions, so just numbers, okay? So if A, B, and C are real numbers and we're told that A is equal to B, then we could add C to A, but to maintain balance, we would also have to add C to B. So what this property does is it allows us to add something to both sides of the equation, which allows us to keep that balance. We could also subtract from both sides of the equation. So you can see right here, if we add C to both sides of the equation, we still get a true statement. The left still equals the right. If we subtract C from both sides of the equation, again, we have a true statement. The left side equals the right side. Now, the multiplication property of equality, this is something that we would use at the very, very end of the solving process, okay? So it says right here, this first bulleted item, says the property is used when the final variable term has a coefficient other than 1. So as we're solving these equations, our goal is to get the variable term all by itself. So we want a single variable term all by itself equaling a single constant term. Once we get to that point, if the variable has a coefficient other than 1, we would apply the multiplication property of equality. So this property allows us to multiply or divide both sides of the equation by the same number, okay? So kind of like the addition property of equality, but instead of adding or subtracting on both sides, here we multiply or divide. So again, we're going to let A, B, and C be real numbers. That means whole numbers, integers, decimals, fractions, just any kind of number that we're, accustomed to working with. And we're told, hey, A is equal to B. So we know the left A is equal to the right B. If we take A and we divide it by some value C, then we can maintain balance by taking B and dividing it by that same value C. Same thing goes for multiplication. If I take A and I multiply it by C, I would still be equal as long as I multiply B by C as well. The only condition here is we want to make sure that C does not equal 0, because if C were to equal 0 when we divided, we would have an issue because we would have a situation where we have division by 0, which is undefined. Okay, so as long as C isn't 0, you're good to go. All right, so let's practice both of these properties. We're going to start by practicing the addition property of equality, then we're going to scoot over to the multiplication property of equality. Okay. So these are just going to be one-step problems, and that'll just get us used to using these properties. In the next video, we'll look at solving equations that require multiple steps. Okay? So example 3 says solve each equation, check the solution. All right? For part A, we have x plus 5 equals 9. So as we're solving these equations, remember that equal sign allows us to solve, which is the process of isolating the variable to determine its value. And as we're isolating the variable, we really just undo what is happening to that variable. So if we look at x plus 5 equals 9, we have x, and what is happening to it is we're adding 5. So how would we undo addition of 5 in math? Well, in math, addition and subtraction, they're inverse operations, so they undo each other. So the opposite of addition would be subtraction. So if I subtract 5 on the left, I would get x plus 5 minus 5. Well, plus 5 minus 5 just becomes 0, and x plus 0 is 0. So we would have isolated the variable. However, remember, we have to maintain balance. That means if I do something to the left, I have to do the exact same thing to the right. So I need to make sure I subtract 5 on the right side as well. So looking at the left side, I do have positive 5 minus 5. That just equals 0. A lot of times as mathematicians, we'll get lazy and we're like, oh, they cancel. Yeah, you can say that the 5's cancel, but please understand why we say the 5's cancel. The 5's cancel because 5 minus 5 is 0, and x plus 0 is just x. And then on the right-hand side, we have 9 minus 5, which is 4. Okay, so at this point, we're like, okay, we've undone some stuff. We've isolated the variable. We've determined its value, but let's just check our work to make sure we're good. Okay, so this is where you kind of need to mosey back to section 6.1. In section 6.1, we talked about evaluating algebraic expressions. And when you're evaluating algebraic expressions, you're given some value for the variable. You rewrite your expression, but anywhere you see that variable, you replace it with the given value and then you simplify. That's how you check an equation. You do the same thing, okay? So we're going to check for x equals 4. We're going to see if that's the solution. So we want to rewrite the equation, but anywhere we see an x, we want to replace it with a 4. So remember, our original equation was x plus 5 equals 9. So I'm going to rewrite the equation, but I'm going to let x equal 4. So I get 4 plus 5 equals 9. And then 4 plus 5 is 9. So we can see the left side truly equals the right side when we let x equal 4. Okay, so we can say now with confidence the solution to this equation is definitely 4. Now there's a fancy way to write the answer. Okay, we use something called set notation. And you don't have to get too hung up on this. I'm okay if you write just x equals 4, but just know that you may see this in Pearson or in your online homework. So when you have something, when you have a solution to an equation, we'll write it in set notation. So we use those fancy curly braces. State the solution. You do not put the variable, you just put the actual value for the variable. So we would want to put a 4 in and then end your curly braces. And this basically says, this translates to the solution set contains the value 4. Okay? Moving on, we've got part B. So part B, we're dealing with fractions. That always complicates matters, okay? So we have x minus 3/4 equals 2/5, okay? So we need to isolate the variable. The issue is the variable has had 3/4 subtracted from it. Remember, this is a goal of like kind of undoing what has happened to the variable. So if we were to undo subtraction of 3/4, we would need to add, because remember, addition and subtraction undo each other. So we want to add 3/4 to both sides. And when we do that, on the left, negative 3/4 plus 3/4 is just 0. So again, we get lazy and we say the 3/4 cancel. Just know that when you add them, they become 0, and x plus 0 is x. And then we got to do a little work because we have 2/5 plus 3/4. So what I'm going to do here, I'm going to show you kind of by hand how we add the fractions, and then we'll go to the calculator and we'll double check. So we have 2/5 plus 3/4. The first thing you have to remember is when you're adding fractions, you have to have what's called a least common denominator. Okay, so the least common denominator is the smallest number that we could divide by 5 and 4 and get a whole number back. So it's the smallest number that's evenly divisible by 4 and 5. So in this case, the LCD would be 20. Okay? So then you have to rewrite both of your fractions and get equivalent forms of those fractions using 20 as your denominator. So looking at 2/5, my denominator is 5. You have to ask yourself, okay, what would I multiply 5 by to get 20? Well, you'd have to multiply it by 4. So I would have to multiply the numerator and the denominator by 4, okay? And then we're going to do the same thing for 3/4. Looking at 3/4, what would I multiply 4 by to get 20? Well, I'd have to multiply it by 5. So we multiply the top and the bottom, the numerator and denominator of each fraction by whatever value is going to make the denominator equal to the LCD. We clean things up a little bit. 4 times 2 is 8. 4 times 5 is 20. 3 times 5 is 15. 4 times 5 is 20. So when we do our final addition here, we're going to get 8 plus 15, which is what, 23? So we get 23 twentieths, okay? But the direction said check your answer. So let's go ahead and take some time to check the answer, okay? So we're going to check 23 twentieths. Now remember, the way we check is we take the original equation, but anywhere you see the variable, hold on, I wrote that down wrong. Anywhere you see the variable, you want to replace it with what value you're checking. So in this case, we're going to replace x with 23 twentieths. All right. So when I do this, I'm going to go ahead and go back to these equivalent forms of 2/5 and 3/5 so that I have a common denominator. So remember, we rewrote 3/4 as 15 twentieths. I need a minus right here. Sorry. So 15 twentieths. And then we wrote 2/5 as 8 twentieths. So now everything has a common denominator, which is kind of nice. And we need to subtract on the left. So 23 twentieths minus 15 twentieths. Well, 23 minus 15 is 8. And we get that 8 twentieths equals 8 twentieths. Everything checks out. So we can write our final answer. We were able to verify that the solution really is 23 twentieths, and we're going to make it fancy. All right, now, as promised, we're going to go to the calculator. Remember, what we were adding was 2/5 plus 3/4. That's what we were doing to verify, not to verify our answer, but to solve the equation. So let's see, do I have the calculator up? I may not have it up yet. I might have to log in. It's up. So depending on what calculator you have, you could type this in different ways. We could type in 2 divided by 5 in parentheses. That's the same thing as writing 2/5 plus parentheses 3 divided by 4. All right, so that's 2/5 plus 3/4. Hit enter. It's going to give you a decimal. And then if you hit the math button, so the two colorful buttons, you've got the blue second button, the green alpha button. Underneath that is math. And if you look, it's got several different menus that pop up, but the first highlighted one is math. We want to do the first option. So hit enter. And this is basically saying, hey, do you want us to take your answer and convert it to a fraction? Say yes. And it gives you the 23 twentieths. Now, if you have this graphing calculator, you can also get the calculator to like kind of create a template for a fraction, which is sometimes easier to work with. So if you hit the alpha button, the green alpha button, and then the very first button on the calculator, y equals, it will pull up this menu right here. And the very first option is the template for a fraction. So hit enter. And here you can type in the numerator and then just hit the down button and the denominator. And then what you have to do is hit the right arrow and it'll take you back out in front of the two, or in front of the fraction, and then hit plus, and then alpha y equals option 1, 3/4. And sometimes this version is a little easier for students to type in. You just have to remember how to find it. And there are other ways to get to it. That's just the most generic kind of set of steps that works for everybody. Hit enter, and we get the 23 twentieths, okay? So you can say with confidence your answer is 23 twentieths, all right? Now moving along, because this video is getting a little bit long, we have part C. So for part C and part D, we're going to apply the multiplication property of equality. So for part C, we have negative 7x equals 63. And remember, the mission here is to undo what has happened to the variable. In this particular case, the variable has been multiplied by negative 7. So you kind of ask yourself, okay, in math, how would I undo multiplication? Well, in math, we undo multiplication with division. So multiplication and division are inverse operations, just like addition and subtraction are. So multiplication and division undo each other, okay? So if you have multiplied a variable by something, to undo that, we would divide by that same something. So in this case, we need to undo the multiplication of negative 7 and x. So we're going to divide on the left by negative 7. But remember, we need to maintain balance. That means if I do something to the left, I need to do the exact same thing to the right. So I'm going to divide both sides by negative 7. And on the left, negative 7 divided by negative 7 is just 1. So again, as mathematicians, we get lazy and we say, oh, the negative 7s just cancel. Just please understand they don't just disappear. When we say things cancel, they either cancel because they add or subtract to become 0, or they cancel because we multiply or divide and we get 1. Okay, so we would say the -7's cancel because when we divide, -7 divided by itself is 1. 1 times x is x. And then finally, 63 divided by -7 is -9. Okay, so let's check our work. So we're going to check x equals -9. Our original equation was -7x equals 63. We want to rewrite that. Anywhere we see an x, we want to replace it with -9. And if we get a true statement, we're good to go. So I get -7 times x, which is -9. And notice I just used parentheses to replace the x with -9. Those parentheses basically become just multiplication, and they hold that negative with that 9 together. And then -7 times -9, we know we're going to get a positive, and then 7 times 9 is 63. So we get positive 63 equals positive 63. Everything checks out. We make our answer fancy. So we can say that the solution set contains the value -9. Okay? Last but not least, we have -3/4 x equals 9/14. Okay. Now, when you have a coefficient that is a fraction, so this final step, you get your variable term equaling your constant term. If the coefficient on the variable is a fraction, there's kind of a shortcut way of dealing with this. Okay. You could certainly just divide both sides by -3/4. That would be fine. You just have to remember that when you divide fractions, it really just becomes a multiplication. In fact, it becomes multiplication of a reciprocal, okay? So we can kind of just get to it. So I'm going to rewrite this just so I have a little bit more room. So I have -3/4 x equals 9/14. The trick here is if the coefficient on x is a fraction, instead of dividing both sides by -3/4 and then converting that to multiplication, just go ahead and multiply both sides by the reciprocal of the coefficient. So we're going to multiply both sides by -4/3. And what ends up happening is over here to the side, I'll erase this in just a second. If I have -4/3 times -3/4, we can say that 4/3 and 3/4 are reciprocals. And we know two things, two fractions are reciprocals if their product is 1. Okay? And when we take this -4/3 times -3/4, we're going to end up getting 1. Because -4 times -3 is +12. +4 times +3 is 12. So we end up getting 1. Okay, so anytime you multiply reciprocals, you're going to get a product of 1. That's kind of the definition of reciprocals. Okay, so we can say over here on the left, -4/3 times -3/4 is equal to 1. 1 times x is x. And then on the right-hand side, we need to do just a little bit of work. Okay, you could just multiply straight across if you want, or you can cancel as you go. I tend to cancel as I go. So I notice that 9 and 3 have a common factor of 3. So I'm going to divide both 9 and 3 by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. Okay, I also noticed that 14 and 4 have a common factor of 2. So 14 divided by 2 is 7, and then -4 divided by 2 is -2. So I can just clean this up a little bit. I get 3 times -2, which is -6, and then I get 7 times 1 is 7. So at this point, we're saying that our solution is -6/7. So let's check it. Now, I do want to erase this side work over here just so I have plenty of room. Okay, so we have -3/4 x equals 9/4, and we want to check x equals -6/7. So -3/4 times x equals 9/14. Replace x with -6/7. You can go ahead and multiply straight across, or you can simplify on the left. I'm going to multiply straight across. So -3 times -6 is 18. 4 times 7 is 28. And then I get equals 9/14. And right off the bat, you're like, ooh, those aren't the same. They're not equal. But they really are, because the left-hand side will simplify. Okay? So notice that 18 and 28 are both divisible by 2. And when we divide both sides by 2, we get 9/14. which does equal 9/14. Everything checks out, so we can write our answer nice and fancy, and we can say that the solution set contains the value -6/7. It checks out. Okay, so this video did go a little long, but I wanted to make sure you really, really understood these two properties, because if you don't understand these two properties, maintaining balance throughout the solving process may be somewhat problematic. Now, in the next video, we're going to look at how to solve multi-step equations. So we're going to have um, equations that are a bit more involved, okay? I think they're more fun though. All right, so I'll see you in the next one.